Take the YTM divided by the coupon frequency. That means I discount for 6-month periods in this case by 3.25. These are my intermediates. I'm going to make him purple. Bond value. If you don't remember the order of the inputs, I already have the function PV, but let's just find it. I type PV and it jumped there. It's kind of a function helper. The rate that I'm using is a period discount rate. Okay. N pair is number of periods, which is number of coupons. PMT is the coupon amount, and FV is the final value or the balloon payment, 1,000. The last argument is optional, so I'm going to leave it blank. One thing you may notice that it gives a negative answer. That's because whoever wrote this function more than likely was an accountant. Accountants think in terms of debits and credits. So if this is the present value of a set of loan payments, if the loan payments are debits, present value must be credit, right? And therefore, I'm going to put a negative in front of this because bond values cannot be negative. Interest rates can be negative, but bond values cannot be negative. Let's make this a red cell. Can you guys see it well in the screen? Because Excel has its own coloring thing. And for later purposes, I'm going to put another thing called, I'm going to call it target value. Of course, we're going to calculate the difference. Sometimes I'm going to tell you what the bond value is, but you're going to end up figuring out at what yield to maturity, for example, you would get that bond value. So let me save this. I'm going to also post it on Blackboard because we're going to play with it. So if you want to play with it, you can download it. Let me call this bond template. Okay, it's down there. I'll wait for you guys to download it if you choose to do so. While you're doing that, there is another yield concept in bonds. It's called current yield. It's calculated as annual coupon amount divided by bond value, or face value times coupon rate divided by bond value. And the purpose of current yield is kind of to be able to make comparisons with stocks. Stocks have a concept called dividend yield, which is expected dividends over the next calendar year divided by the current value of the bond stock. For example, let's look at Coke. Right here in the summary page, it's called forward dividend yield, 3.7%, 3.07%. That's the expected dividend over the next 4 quarters divided by the current price. Okay. For the purpose of making a crude comparison between the yield of bonds versus stocks, the people who play with bonds came up with the concept of the current yield, which is effectively the dividend yield for the bonds. You know, what's the dividend for the bonds? The coupons that it's going to pay, right? But don't ever compare bonds based on current yields because that depends upon a lot of stuff. One thing about if the bond is a premium bond, which means bond value is greater than face value, and premium does not necessarily imply a positive connotation. It just means the value of the bond is greater than face value. That means yield to maturity is less than current yield, which is less than coupon rate. So this is for premium. If the bond is a discount bond, I'm sure you know what that means. Bond value is less than face value, which necessarily implies that YTM is greater than current yield, greater than coupon rate. Okay. I don't know why I made them red and green. I just did. And if you look at here, oh, let's make this a bit smaller. Let's also calculate inserts. Take the face value, multiply it with coupon rate, divided by the bond value. As you can see, yield to maturity is lower than the current yield, which is lower than the coupon rate. In the rare case that bond value is exactly equal to the face value, that's called a par bond. Then coupon rate, YTM, and current yield will be exactly the same. Now let's ask ourselves different questions. Suppose a bond, a 10-year semi-annual 6% bond is trading at 105% of the face value. What is the implied YTM? Assume face equals 1000, then bond value is equal to 1050.